Hi guys, welcome back to my channel. Today we are going to work on section 4.5 again. What we're really focused on is learning target 4b, and learning target 4b is multiple strategies of solving quadratic equations in standard form. And so we have seen factoring in the zero product property before. We are not going to do the completing the square yet. We're not going to do quadratic formula yet. We are going to do graphing today. And then we're also going to talk about kind of one other strategy that's sort of works okay, but it's not quite for standard form. So it's just another thing that you kind of have to know. So here we go. These are the three forms of quadratic equations that you're going to see, quadratic functions that you're going to see. You can get all of these important features that I've been talking about off of all of these. You know how to do a lot of these things with standard form, especially, and with vertex form. Factored form we're a little bit less familiar with, but remember that you can use the box method to multiply out factored form, and then all of a sudden you're back to standard form, and so then you're kind of back in that place of comfort. So that's that. The main thing that we are focusing on for this lesson is solving equations, and what that usually means is we're looking at x-intercepts on the graph. So that's really the focus of today. So we're going to go from there. I just wanted to quickly remind you about the first solving strategy that we've done so far this unit, and the first solving strategy was factoring in the zero product property. I just want to remind you really quickly that it's really critical, and you have to know this, that you can only use this strategy when this equation looks like ax squared plus bx plus c equals 0. Notice that this one is not equal to 0. Zero, so we can't factor yet. The thing that you have to do then is you have to get it to be equal to 0. So I'm going to do that. I'm going to do that a little bit of a funky way. I'm going to subtract 8p from both sides, and I'm going to get 0 equals -9 plus 9p plus negative 2p squared. I needed to subtract negative 8p. I hope that 8p squared. I hope that I said that all right, but maybe I said it wrong. I need to subtract that negative 8p squared. Sorry about that. Okay, now I have something that looks sort of like standard form, but I'm not quite there yet. And the reason that I'm not quite there yet is I'm not in the right order. So I'm just going to rewrite it in the order that I'm more comfortable with. 0 equals negative 2p squared plus 9p minus 9. Remember that it doesn't really matter what order you write things in as long as the right things are positive and the right things are negative. And so now I can identify what is A times C, and my answer is going to be positive 18 here. What is B? It is 9. So what are the two numbers that multiply to 18 and add to 9? I'm going to be using 6 and 3. Okay, so in the box method, I'm going to put my negative 2p here, squared. That's that part. I've got to have my minus 9 here, and then I've got to use my 6 and 3 to get to this point. So I'm going to have my 6p and my 3p, like that. Okay, what is common between these two terms? Well, let's use a 3 here. 3 goes into 3p and negative 9. But I have a negative 9, so this has to be a negative 3 here. If that's negative, then this has to be 2p, but it's got to be negative because otherwise I won't have a positive number here, which is important. And then what am I left with? I'm left with just p here. So my factoring looks like this. P minus 3 times negative 2p plus 3 equals 0 because it was equal to 0 here. Then I can apply the zero product property, ZPP, and I can say, okay, p minus 3 equals 0, and then negative 2p plus 3 equals 0. Solve both of those equations. I get p equals 3 as one solution. Minus 3 minus 3. I get negative 2p equals negative 3. Divide by negative 3. Sorry, by negative 2. And I get p is equal to 1.5. Okay, so my two solutions are 1.5 and 3. That's that first solving strategy. It's factoring in the zero product property. That is one of the things that you can use for these types of problems. The next thing that you can use with these types of problems is just getting x by itself, kind of using what we usually are comfortable with using algebra, undoing operations. So this really works with vertex form. So we're not directly meeting objective 4b here, but really it is still like, okay, we're working with quadratics, we're solving equations. This is another strategy that you can use, and you might not always see your equations in standard form. So I want you to be a little bit flexible and see that vertex form, you can still get answers out, even though the techniques are a little bit different. So what I'm gonna do is I'm gonna get x by itself. So I'm gonna subtract 18 first from both sides. I get negative 18 equals negative 2 times x minus 4, squared. I got to divide both sides by negative 2 first. You all might be like, oh, we got to distribute this 2 through here, but that doesn't work because this square happens first. So you can't touch the distributing until you do the square. So we kind of have to undo, like take pieces away instead of trying to distribute that 2 through. This will also save a little bit of time and some steps. So let's go with that. So we're going to end up with 9 equals x minus 4 squared. Now you might be like, okay, so if something squared equals 9, then this stuff over here has to be 3. But that's not exactly true because there's another solution. Remember from like a long time ago that like when you take a negative number and you square it, you still get a positive number. And when you get a positive number squared, you still get a positive number. So the two answers that I could get from this equation are either negative 3 or positive 3. So I could say x minus 4 is equal to positive 3, or I could say x minus 4 is equal to negative 3. So then I'm going to add 4. I get x is 7. Here's one solution. Add 4, and I get x is 1. There's the other solution. So a little bit of messing around, but remember that you should be getting 2 answers most of the time when you're working with these quadratics. And remember that that's because, hey, look, this thing opens down, has a vertex of 4, 18. So this graph looks something like this, right? There are 2 places where this thing crosses the x-axis, and that's what I mean when I say 0 equals, because that's the y value 0. So that's the equation that we're solving. That's the graphical representation of the equation we're solving. Okay, so I don't know why this kind of copied weird, but the second strategy is solving for x by like undoing the steps, undoing the stuff around x. So I'm going to do one more equation just as an example. Reminder that this works really well for vertex form, and yes, we are in vertex form, so we can get x by itself. So I'm going to add 49 to both sides. Get 49 equals x plus 4 squared. I wrote 4, I meant 49, sorry. Okay, so now you're thinking in your head, what are the 2 things that when you square it, you get 49? What are the 2 things you square to get 49? The answers are either 7 or negative 7. So you can say 7 equals x plus 4, or you can say negative 7 equals x plus 4. Okay, So then, minus 4, minus 4, minus 4, minus 4. I get negative, sorry, just kidding. I get 3 equals x here, and I get negative 11 equals x here. So my two solutions are 3 and negative 11.